Lesson 29 reviews bolt hole bearing strength and bolt spacing issues. When designing bolted connections, consideration must be given to the bearing forces introduced into the connected plates by the bolt forces. High bearing forces can cause local failure of the steel in the plate contact region. The steel strength in the bolt is much higher than the plate material, so it is the plate that is of concern. Bolt bearing becomes more of an issue if the connected plate is relatively thin and the bolt is relatively large in diameter. Because the plate steel is confined by the washers and bolt head, a relatively high bolt hole bearing strength can be used. Bolts must be properly spaced from each other so that the bearing stresses from a bolt does not overlap adjacent bolts. The minimum distance between bolt holes is 3 times the bolt diameter measured to the center of each hole. However, as we saw when we were studying tension members, a standard hole spacing of 3 inches is usually used. This is good for bolt diameters up to 1 inch in diameter. These provisions apply only to standard and holes slotted in the perpendicular direction. Bolt holes that are placed too close to the edge of a plate can tear out at the end of the plate. Think of a sheet of paper tearing out from a 3-ring notebook or binder. Note that we have been using 1.5 inches for our connections and tension members, which is good again up to 1 inch diameter bolts. We now want to determine a strength value for this tear out. We assume 2 shear planes form when the bolt tries to tear out at the end of the plate. Each plane has a strength of 0.6 times F sub y times the surface area of the shear plane, which is little L sub c times the plate thickness. It is important to note that the lowercase L sub c is not measured from the center of the hole. Instead, lowercase L sub c is measured as the shortest distance between the hole and the end of the plate. Use the net diameter in the calculation of L sub c, meaning include the 1/8 inch increase due to the hole oversize and the damage. This is about the only time the hole center is not used in calculating a distance. Note that the direction of the applied force is parallel to the measured distance L sub c. The formula that we will use in this class to check bolt tear out and bolt hole bearing is shown. The first set of terms is for bolt tear out, while the second set of terms is for bolt hole bearing. There are other similar formulas that can be used when more deformation is tolerable in the design. When considering edge distance perpendicular to the line of force, AISC table J3.4 can be used. These distances are measured from the center of the hole to the edge of the plate. You should still consider using the standard edge distance of 1 1/2 inches, but in a pinch, where space is tight, you can use the smaller tabular values. When designing bolted connections, consideration must be given to providing proper clearance between bolts. This includes leaving room for the socket and tools that are used to tighten the bolt. The minimum spacing requirements are given in AISC Table 7-15 and 7-16. Spacing between bolts should not get too large, otherwise buckling may occur if the plates are in compression. Also, corrosion can occur in the gaps between the bolts. When steel corrodes, it can expand up to 15 times its original volume. This can cause the plates to separate and result in prying of the bolts, which is not good. See section J3.5 for maximum spacing limits. This slide summarizes the bolt hole strength calculations. Generally, the bolt hole bearing strength controls unless the hole is near the end of a plate and can possibly tear through the end. You need to look at the direction of the force in order to determine if the bolt will tear out. The lower bolt in the right-hand connection will be prone to tear out, but not the upper bolt, since the bolt force is acting downwards. The upper bolt in the left-hand connection would not be prone to bolt tear out, since it must tear through the beam flange as well as the web plate. Now, if the beam top flange were to be coped or cut off, then bolt tear out would probably control. This ends lesson 29 and module 12.